Inverse functions. Okay? Today we're going to be finding the inverse functions. Find the inverse of a function. Find the inverse of a function. I don't even think there's any other instructions on here, but find the inverse of a function. Okay? Can you tell what we're doing today? Oh, finding the inverse. Okay. So, in order to know how to find the inverse, can I just tell you how to find it? Switch x and y. How do you find the inverse of a function? I want you to say it out loud, please.
Switch x and y.
I'm going to ask you again. How do you find the inverse of a function?
Switch x and y.
How do you find the inverse of a function?
Switch x and y.
So why did I have you say it 3 times?
So it'll stick in our
It'll
brain.
stick in your brain, right? Now, you're always going to switch x and y. Sometimes, well, actually most of the time, then you'll have to solve for y. Okay? But if you can remember to switch x and y, you're going to remember to solve for y. So to find the inverse of a function, you switch x and y. Got it? I want you to please put a box around number 1 and put a box around number 3. We'll put more boxes, but for sure those 2 at the beginning. I'm going to do these for you. So when we see each other next and I say how many did you do, how many extras you do, we're not counting the ones with boxes, so then nobody's confused. Is that fair? Okay. So we're going to start off by doing number 1. Okay. Now remember, this is something you already understand. You can handle this, right? You can handle this, but how do you find the inverse of a function? Say it. Switch x and y. So if I give you a list of ordered pairs, what are you going to do with those ordered pairs? Switch x and y, which means I'm literally writing -3, 1. I'm literally writing 3, -2. What am I doing? Switching x and y. So, can you tell that there's no reason to panic about this?
Yeah, I hope so.
Now, does it get harder?
Yeah.
Yes, right? But if that's one of the examples of the questions you have to do,
That's pretty easy.
that's pretty easy. Okay? So, this is if it's given to you as a list of ordered pairs, right? What if it's given to you as an equation?
We got to solve it for
That's when we're going to have to solve for y, right? But what do we do first? Switch x and y, okay? When I switch x and y, I'm going to come over here, and I'm going to write x equals 3y plus 2. X equals 3y plus 2. Well, I already switched x and y, so what do I need to do now? Can you tell me why I need to do that? Yeah, don't just say because I said, right? Because that doesn't do you any good. You don't know why. You don't want to do stuff just because I told you to, right? Is this how you're used to seeing these equations? No. How are you used to seeing these equations? Y equals. So does it make sense? Is that a good reason why we have to solve for y? It needs to be in a form that we're used to. Okay? So, how do we go about solving for y now? What do you think I do first?
You definitely should move something over.
I should definitely move something over. What should I move over first? The 2. I think that's a great idea. So if I subtract 2 from both sides, then what happens?
You got negative
Yeah, x minus 2. X minus 2 equals 3y. Am I done? Why not?
divide by 3.
Yeah, the 3 is still there. I have to divide both sides by 3, right? Now, what am I dividing by 3? The whole side, right?
Right.
Divide by 3. Now, here's we're going to have a quick conversation. Okay? X minus 2 over 3. Is there anything wrong with that?
No.
How do you feel about this? Are those 2 equal?
Yes.
Isn't this,
That's 1 over 3.
and that's 2 over 3, isn't it? So I need to know which one you think is more correct. They are the same, aren't they? Okay? Now, there is times You're going to want one more than the other, right? If I suddenly say graph this, that's not easy. But here I have a slope and a y-intercept. I can graph that super quick, can't I? I could plug numbers in here, right? That's not a big deal. I could still do it. But if it's in this form, that's in slope-intercept form, and that's real easy to graph, right? But is either one of these wrong? No, absolutely not. Okay? Now, I have to be a little picky right here. Neither one of these is the answer. Kind of. Okay? Would you remember for me, please, what this means? What does f of x mean?
Why?
It means y, right? It means y, and that means if that's there, if f of x is there, that means we're talking about specifically about a function. Okay? One of the things that is on our list of stuff that we have to do is I have to make sure you understand function notation, right? It means I have to make sure you understand that f of x equals y, right? For us in Algebra 2, right? Okay? The other thing about function notation is that there is a notation for an inverse of a function. And it looks like this. Now, does this -1 look like an exponent? Yes, it does, right? It absolutely looks like an exponent. Is it? No. It is the notation with the f to tell you that we're talking about the inverse. Okay? So we didn't do anything wrong, and we got here, but now when it's time to write our answer, what we have to write is f -1 of x equals x minus 2 over 3. So was this almost the answer? Yes, just not in the right notation. Does that make sense? So this is what we're looking for the answer. Now, could I have written right here 1/3 x minus 2/3? Absolutely, right? And both of those are correct, right? But I'm just telling you that's an option. But we've got to have our answer right here in function notation. Does that make sense? Any questions? You okay so far? Couldn't you have done that in August? Yes? Okay. Would you please look down at 11? You don't want me to do any hard ones? You want to do them all by yourself? Oh, okay. So I should go ahead and do it? Okay. Did you talk about squares in Algebra 1? You did, right? So you could have even done this one in August, couldn't you? Maybe with a little help, right? So what do I do first? How do I find the inverse? Say it out loud. Switch x and y. Everybody say it out loud. Switch. So first of all, I get x equals y plus 3 squared. So I had to figure out how to undo a squared. How do I undo? Yeah, that's exactly what I do, right? Isn't that undoing a squared undoing a squared is by square rooting it? Did you talk about that in Algebra 1? No. Okay, that's why we needed to wait. Do you understand? Okay. Now, I have to be, guys, I have to be real picky here. Okay? Not because I'm just being mean, but because if you don't write what I'm about to show you, it's just wrong. Okay? So we're going to take a quick commercial break. We're not talking about this problem for just a second. We're taking a quick commercial break. Okay? I need you to remember back when we talked about square roots, finding square roots of numbers and things like that, right? We talked about square roots of regular numbers. We talked about square roots of negative numbers. We talked about i's, all that kind of stuff. We're not going that far. We're not talking about i's again. But I want you to think back to when we talked about square roots of numbers. What is the square root of 4? See, that's what I was afraid you were going to say. So I need you to think for just a second. You're not wrong. You're just not done. 2 and -2, right? The plus or minus. Do you remember how important that was? Because we have 2 solutions when we take a square root, right? And even more, I'm going to get even more specific for you there. We have 2 solutions when we take an even root, a square root, a 4th root, a 6th root, right? So anytime we're taking the square root or an even root, when I go to write my next step, I actually get the square plus or minus the square root of x. Right? Because if all I write is the square root of x, I've only written half of the answer, haven't I? Very good. Okay? So, am I done? No, but what do I have left to do? Only subtract 3, right? Now, I need you to be cautious when you write this because I have plus or minus the square root of x. Is the 3 inside the square root? It's not, right? So you have to make sure that it's clear that it's not. Does that make sense to everyone? So this is what I got when I switched to x and y and solved for y. Now, what do I write for my answer? F negative 1 of x equals what we just got, right? Plus or minus the square root of x minus 3. That is my answer. Does that make sense? Do you have any questions about that? Okay, would you turn the page, please? Now, before we start number 19, let's go ahead and box it. Box number 19. But before we start it, I need you to, I forgot something when I typed this. Would you add our little baby 4 right there? I just forgot the 4th root. Okay? Now, guys, what is this? That's a restriction on that equation, isn't it? Why do I need a restriction on this equation? Well, because it's an even root, right? Even roots, this can't be negative, can it? So when I solve for the inverse, I ignore that. It has to be there for part of this or for whatever this particular equation is talking about. But when I'm solving this, when I'm trying to find the inverse, I just ignore that part. You okay with that? Okay. So how do I find the inverse? Say it out loud. Very good. So x equals the 4th root of 2y minus 7. So what do I do first? Does it really matter what I do first? Oh, absolutely, right? Absolutely it matters. What should I do first? I have to isolate my root before I can do anything inside of the root, don't I? I don't even know what I'm saying anymore. We're good, right? Okay, so x plus 7 equals the 4th root of 2y. Now, how do I undo a 4th root? How do I undo a square root? Square it. How do I undo a 4th root? It's a good guess. So you know what to do, you just don't know the words. Is that what you're telling me? Yeah. So somebody earlier said fourth it, right? That's a little too close to another F word, so let's not say that, okay? Let's say raise it to the 4th power. Are you okay with that? Whatever the root is, that's the power I should raise it to. So I'm going to raise it to the 4th power. If I raise that side to the 4th power, don't I have to raise that side to the 4th power? So on the left-hand side, I get x plus 7 raised to the 4th power. And what do we get on the right-hand side? 2y. Just 2y, right? Because if it's a 4th root raised to the 4th, don't those go to 1? They cancel, right? So what do I have left to do to solve for y? Okay? Now, I'll tell you, in algebra and in life, it's never a good idea to go too far. Okay? Do you want me to take this x plus 7 and write it 4 times and distribute all those out and solve that way? No, absolutely not. Could I? Yeah, like if I was getting punished. No, I'm just teasing. Okay? Sometimes we have to do that. Definitely not today. That's as far as I need to go. Okay? That is as far as I need to go. Now, I will ask you this question. What if I wrote 1/2 times x plus 7 to the 4th power equals y? What would you say to that?
Okay.
Would you say okay? Would you say that's the same? Because this divided by 2 versus this times 1/2, isn't that the same thing? Do you care? I would only care if I was graphing, right? Because if I'm graphing, oh look, I can do transformations now, right? That is a vertical compression, a vertical shrink, and then it's a shift to the left 7, isn't it? Okay? But now I come over here and write my answer, f negative 1 of x is whichever one of these two I decide on, right? X plus 7 raised to the 4th over 2. Any questions? You okay so far? I need you to look at 26 for me, please, and cross it out. And I need you to write instead f of x equals negative 2x to the 3rd plus 1. Because somehow I accidentally put the same problem on 24 and 26.
Wait, what does it say?
On number 26. Now, why do you think the graphs are there? Because I want you to graph it, right? Now, we're not actually going to do one of those, only because we're going to do one of these, and you'll understand what to do on one of these. Does that make sense? Okay, so would you please look at this one? Let's go ahead and put a box around 27 so you know we did that together in class. Okay. Find the inverse. How do I find the inverse if it's a graph? How did I find the inverse of this? Don't I have an x and a y here? Don't I have 5 x and y's? 1, 2, 3, 4, 5. So couldn't I decide that this is 2, 3, and instead graph what point? 3, 2. Couldn't I say this is what? 1, 0? What would I graph instead? 0, 1. What? No, I'm not changing sides. I'm only switching. Remember, just switch x and y. Good question, though. What about, let's see, I did that one and this one. What about this one? That's 0, negative 1. So what do I need? Negative 1, 0. What's that one? Negative 1, 0. So what does that become? 0, negative 1. And what's this one up here? Negative 2, 3. So what do I need to graph instead? 3, negative 2. Now, the next thing I'm going to do might blow your mind a little bit, just a little bit. Okay. Tell me again, please, how I find the inverse of a function. By switching x and y, at some point in your brain, are you thinking that x and y are equal? If I'm switching them, aren't I kind of making them equal to each other? Well, watch this for a second. If I graph the line y equals x, that's there, 2, 2 is there, 3, 3 is there, 4, 4 is there, 5, 5 is there, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3, negative 4, negative 4, negative 5, negative 5. if I graph this line right here, the line y equals x, what would happen if I took my paper and folded my paper along the line y equals x? Isn't this going to be right on top of that?
Yeah.
Isn't this going to be right on top of that? Isn't this going to be right on top of that?
Yes.
What? Isn't that pretty cool? Isn't that in fact a way to find an inverse? If I was more of a visual person, couldn't I graph one and then fold it along the line y equals x and find it that way? Absolutely, right? Okay? So here, like on this problem, I need you to graph this. Use your calculator or use transformation rules. You know how to do both of them now. Graph it, but also find the inverse by switching x and y and solving for y and finding an inverse and then graph the inverse. I also want you to graph the line y equals x. Anytime there is a graph, I need you to graph the line y equals x. Okay? Because then you're going to know, did I do it right? Because you could fold it on that line and see if they're on top of each other. Does that make sense? So on all of these graphs that you do, you're graphing also the line y equals x. Does everybody understand that? Are there any questions on how to find the inverse of a function? Tell me again, how do you find the inverse of a function? Switch x and y. Okay? I would like you to work on your work. Is it a good day for board points? Yes?